Hey guys, welcome to another video. My name is Sanjit, and in this video we'll be talking about the factors that are affecting lift, and we will also relate these factors and formulate the formula for lift, and we'll relate everything together. This is important because of course it's in the syllabus and we have to talk about it. So I have created this board in which I have spoken about all the factors that are responsible for the creation of lift, right? So the first factor is the wing shape. The shape of the wing, as we know, is very important. It can be a symmetrical aerofoil, it can be asymmetrical aerofoil. In the near future we'll be talking in detail about this. So the wing shape matters a lot for the creation of lift. The angle of attack. So the angle of attack is, I'll put it in brief, but there will be a whole another video talking about the angle of attack and the angle of incidence. Is the angle made by the relative air and the chord of the aerofoil. So that is what the angle of attack is. Tune in for the next video to understand what the angle of attack is. Third is the air density. We have already spoken about the density of air, right? So the density of air, if there is less air, how can we have already understood that air coming in is the reason for lift to be created. Air is what pushes the aircraft upwards. So that is how lift is basically created. So the air density means the number of air molecules that are present there, right? So the weight of the air, basically, that's what is the reason behind the lift in a way, if you look at it. So the air density also is a very important factor. The free stream air velocity. So as the air keeps moving over the wings, then only there is a chance of creation of lift. We have already seen this. Streamline flow coming in creates lift. Surface area of the wing. Again, the surface area has always been an important factor along with the wing shape, right? So again, a quick review: wing shape, angle of attack, air density, free stream air velocity, and surface area of the wing. These are the factors that create lift. Now, lift, I want to read out a certain line to you. The dynamic pressure, so they want to say basically that the combination of dynamic pressure and a wing's planform surface area produces a force which is proportional to the area on which it acts. This force is known as lift. So what they mean to say is lift is the product of dynamic pressure and surface area, right? So lift can be put as so we have already told that the free stream air velocity is very important. So lift can be a product of the dynamic pressure and the surface area, right? Now we remember that dynamic pressure's formula is half rho v square, right? We remember this, and the S is the surface area. Now I want to also remind you that, and I would like to put this in the actual terms, in actual scientific terms, because this actually comes on your exam. They say that lift does not directly equal the product of two terms, and therefore the lifting efficiency of the wing also need to be taken into account, okay, which would be called as a coefficient of lift. Okay, so it is coefficient of lift can basically be the capability of a wing to create lift, right? It has the capability, basically a wing or an aerofoil is not always creating a positive lift, right? It can also create a negative lift these days. So it's the capability of any wing to create lift. So that also is taken into account. So three things are being taken into account while you look at the formula. The first thing is the coefficient of lift. The second thing is the dynamic pressure. And the third thing is the surface area. So put these three things together and it is giving you coefficient of lift into half rho v square s. Okay, so coefficient of lift is basically the the capability of the wing to create lift, and then half v square is the dynamic pressure, half rho v square is the dynamic pressure, rho is nothing but the density of air, v square is the velocity of air, and s is the surface area. So all these things put together is basically the formula of lift. So basically the formula is, if you remember it in basic terms, it is basically the dynamic pressure, the surface area, and the coefficient of lift, which would finally come as CL into half rho v square s. Okay, so that is the formula of lift. Happy landings, guys. Cheers.